Yeah, welcome to Learning SuperPro Designer for Students, Example 1. A SuperPro Designer is a software package for simulating processes, setting up a complete plant, and so on. It's a great software tool. However, it's of course not an educational software. Nevertheless, we implement that in our study courses and at the end, the student should build up a company using SuperPro Designer. This is, of course, for one semester a real effort because the software is quite complex. And as it's not educational, sometimes the learning is not so easy. So therefore, this example is a tailored program for students Bioengineering Bachelor of Science, Biotechnology, 5th semester, in order to learn the software. And the first example is a very simple example, just setting up a very basic unit in order to get the first ideas of the program. This is not a video showing you what SuperPro Designer can do. There are other videos for that. This video is tailored in order to learn how to use SuperPro Designer. This is the first example, and the PDF document of the example, which I highly recommend if you want to do that, is in the description. It's a link in the description. I would download it and use it. There is also a long version of this video, which is an excerpt of the complete lecture. And of course, there are then more insights in the program. So here we go. Okay. So I start now the SuperPro Designer. You see on my mess on the screen. So, and now the first question which is asked is, what would you like to do? Start a new process file, open your last process file, open another process file, or we'll choose later. Of course, in this case, we start a new process file. So, and now the next question is, what process operation mode do I want to do? Most process operation modes will be batch processes, but you can also go for continuous processes. In this case, for example, wastewater treatment plants and so on are really in a continuous mode. But in general, most processes will be batch operation processes. So this, I don't care at that point. I just start now and say, okay, a batch process, we start. Okay, here we go. So here we are. So this is how it looks like if we just open the software. So our first example is a very simple example. It's just neutralization of an acid with a base. So this is not rocket science chemistry, but this is just to show you how the software really works. So you see the purpose is that we want to set up this simple neutralization process. And what we want to do is we want to neutralize 20% acetic acid with 15% sodium carbonate. Of course, it's clear that the reaction product of this neutralization process is simply sodium acetate, the salt, and you will have production of carbon dioxide and water. So therefore, the first thing to do is, if we start with a process, we need to collect all substances we use in our process. If we want to put in substances, we need to initialize the substances in the software as described here. So we go into tasks. Here we go. Pure components. And then I go to register edit properties. Yeah. Here we go. And now you get this nice little windows. And this is the components registration dialog. And now what we do is simply we search and select each component we need to add. And this is simply copy, more or less copy and paste. So here we go. Here we are. So now here we have found, this is a components database. So these components are in the database and we will see a second what that means. And we register it. Now I just click on register. And here we have then a list of the registered pure components. You have to do it then yourself. You get used to that. So this is just showing you how that works. Now we have the first component registered. Now we go with a second component. It's sodium carbonate. Here we are. Register. Oh, an alarm. So now you see component sodium carbonate is missing the following physical properties that might be needed for simulation. Eccentric factor, gaseous heat capacity, vapor pressure, heat of vaporization. And what now? So you see that there are properties in these substances, not just the substances, but also physicochemical properties deposited in the database. And obviously, for this sodium carbonate, the eccentric factor is missing. At this point, I don't care. So I have seen, oh, something is missing. And if I see a procedure where I see, ooh, this sounds like a separation procedure where maybe the heat of vaporization comes into play, then I would go and look up this value in a list and so on. But as long as I say this is unlikely that I need it, then everything is fine. However, you should have a look on the list. So heat capacity, vapor pressure, heat of vaporization. You say it's sodium carbonate and it's in solution. So therefore, it is unlikely that these three terms we really need. Now we go on. We have the sodium carbonate. We have the sodium acetate. I get an alarm. Critical pressure, eccentric factor, vapor pressure, heat of vaporization. So also here we have a list, and also here we say this is in solution, or this is not in our conditions. We plan to do our neutralization, that it's relevant. So also here, okay. But have a look on this list first. This is important. If you realize that something is missing, what you know, what you need, then you put it in immediately and don't wait before you get an error. So, and now we need carbon dioxide. And then everything is fine. So now we have all our substances. We have acetic acid and sodium carbonate, which are our reactants, and our products are sodium acetate, carbon dioxide, and water. And you see nitrogen and oxygen, it always puts by default, and that's fine. So therefore, we have no problem there. Okay, so we're happy, and we click now. Okay. Now we come to the problem that the component sodium acetate, the pressure must be above 0. And you remember, we have neglected it. We didn't care about that. And now we could, of course, look it up in tables or something like that. But this takes ages. So let's double click on that. And now you see, wow, we have here a vast array of values which are put in, the temperature, the critical properties, and so on. But what was missing was the critical pressure. We have no idea how high this critical pressure should be. However, we know that for our process, the critical pressure is of no relevance at all. So I simply put in 0.01 bar, which is certainly not correct. And I click OK. And I click again, OK. And now we have registered our substances. However, you should not save that in the default database. Now we want to add a procedure. Now that's the big day. We start with now adding a unit. And of course, what we do is we go to unit procedure and we add a batch vessel procedure in a reactor. So what we add is now a simple vessel procedure. Here we are. So what we do now is we add streams. So we go to this tool here and add streams. So I add the first stream here, next stream here, then I add a stream here, and I add a stream here. Okay, so I've just added streams with this stream tool. You see, as soon as you go next to this ports, then this changes and then this edits it. Don't draw streams just like this. Yeah. they always have to edit somewhere. So you need to start here or you need to end here. Yeah? So now what we have to do is we have to initialize the screen. So what we want to do is we want to initialize the stream 101. So we just double click on the stream. The first stream is our acetic acid stream. So we need to put acetic acid and we need to put, of course, water. So this is what we put here. So now our stream has a composition of 100% acetic acid. This is a lot. And 0% water. Of course, we need to change that. It's 20% acetic acid, mass composition, and 80% water. Now we have added that. And now we set the mass flow to a flow rate to 1000 kilogram per batch. Okay. So now this is 20%, 80%, mass flow is set. Okay, so now the stream is initialized. Now we could also initialize the second stream the same way. You remember this is then the sodium carbonate stream, but we will initialize it in a different way, just to show you that there are different possibilities how to initialize streams. Okay, now we set up the vessel operations. We right click on the vessel and then you see different things appearing. So we have add remove operation and other things. At this point, we don't care about the other things. We go for add remove operations. And there are a couple of available operations. And of course, the operations depend on what unit you choose. If you have a disk stack centrifuge, the operations will be different to the operations you have in the vessel procedure. Want to know what is this unit about? Also here, right click. Help is a good idea because then you get an overview about this process. You get an overview of the operations and you can click on an operation like the charge operation and then it's described for what this operation is used. Obviously, we need to charge the acetic acid. We need to charge the sodium carbonate. They need to react and then we need to transfer out. So we add one charge operation and we add another charge operation. We need to charge two things. For each stream, we add a charge operation. Then we add a react operation. We have a reaction going on in this reactor. Now you see, we could also add mix operations and so on, but we don't care. We just make it very simple now. React equilibrium, react kinetic, react stoichiometric. We remember bioprocess engineering, kinetics was so complicated, so we don't touch this button. We just go stoichiometric. So there we are happy. Reaction, stoichiometric reaction. And then at the end, we need to pump everything out. And this is then a transfer out operation. Now we want to set up the operations. Now we are at point 2.7 and we first of all set the charge one operation. So now we don't go to add remove operations. Now we have a new topic here, which is operation data. And we go to our charge one operation. We need to tell the software what stream to use. So we want to use the stream 101 for this charge one operation. So we charge using stream 101. It's not port 1. You see on port 1, there is nothing. You just look where we have our 101 stream. That's it. And then you remember we have initialized the stream. So the amount we want to charge is the amount which is given in this stream. So everything was written in the stream. So we click here, amount, use amount of stream. And then everything is fine. The remaining part we leave untouched. So the setup time and so on, we keep. Okay, so we have initialized our first operation. Now you remember our charge 2 operation was a bit different because the stream of the charge 2 operation was not initialized. So in the stream, we have not told the software what is in the stream. So of course, for charge 2, we take the stream 102. We take the stream. But now we need to tell the software first, before we proceed, what is in. So therefore, we go to this symbol here. We go to this symbol, click it, and you see it's view edit the streams composition. And here we are, a new window opens. But the cool thing is that you have already seen this window, because this is exactly the window which gives you the stream composition. That's cool. Yeah? It's something which is not new to you. So you go there and you remember the first stream was our acetic acid stream and the second stream is our sodium carbonate stream. So what you do is you simply add sodium carbonate, add ingredient, and of course also here water, add ingredient. So now we have initialized the stream, and now the same is true. We need to correct the percentages. So sodium carbonate is 15%, and water, don't forget to adjust the water, it's 85%. So this is our stream composition. Now we don't touch here these flow rates, and you cannot change them anyhow here. So we just have given now the composition of the stream. Okay. And now we need to tell the software how much is being charged. So we cannot use the amount of the stream because the stream in this case just contains the composition. We want to set it here. So mass flow, we add also here 1000 kilograms. And the remaining things also we'll leave untouched. Okay. So now we come to the reaction tab. And this is, of course, now the King's discipline. So we use a stoichiometric reaction model. You see what's written here. So we need to, if it's a stoichiometric model, we need to tell the software about the stoichiometry. We go now to, this is the first tab, but we go now to the tab reactions here. So not operation conditions. Here we leave everything the same, but we now go to the reaction progress. And here we have set conversion. So here we can say how much percent to convert. In such a reaction, this neutralization reaction, we allow 1 hour. We have set the time to 1 hour, and this will be 100%. So we have no problem here. So this is, of course, something you need to know based on your vast knowledge in chemistry what you can put here. It's the software doesn't complain. If you put in here 100% and it's an equilibrium reaction, and this can be, the software will convert to 100%. If you give a time of 1 minute and it takes 5 hours for the reaction to proceed, and you give it nevertheless a conversion of 100%, the software will do it. So it's up to you to come here with values which are reasonable. Now we have to edit the stoichiometry. So this is our first reaction, and we have to go to the stoichiometry of the selected reaction. So we have to tell the software what is happening here. Now we have here, we need to add our reactants, and we need to add our products. So here we go. So let's add our reactants. And we have acetic acid. And we have sodium carbonate. It's not the water. The water gets in, but it's not involved in the reaction. It's not a reactant. It's a solvent. And of course, what we produce is sodium acetate, carbon dioxide, and water. You see that now the masses are not balanced. You would need to set up the stoichiometry correctly, but this is of course easier if you use, instead of mass coefficients, then molar coefficients. So here we go. We click on molar, and you see now also the molar coefficients appeared. 2 molecules of acetic acid react with 1 molecule of sodium carbonate, yielding 2 molecules of sodium acetate, 1 molecule carbon dioxide, 1 molecule of water. This is the reaction stoichiometry, simple. And you see then, of course, then the mass in this case is balanced. Okay, so we're happy with that. So we have added the reaction, we have added the conversion rate. Often this is forgotten because the default value there is 0. And then, of course, nothing happens. And we're quite happy with what we have done now. And so we say, okay. Now you can always say, okay. But what you can also do is making life simpler. In this case, if you click here, it's okay. Next operation, then you don't have to redo this right click and so on. It's just then quicker. You go directly to the next operation and everything what you have put in is saved. Okay, next operation. And now we come to our transfer out. And the transfer out stream, this is this one here. This is this 104. So we use stream 104. Here we are. Okay. And now the big moment comes, because now we have set up all our streams. And now we perform the mass and energy balance. By the way, what I did not yet do is save. Don't forget to save regularly. Okay, now I perform the mass balance. This is the big deal. So I go to this symbol here and I do solve the mass and energy balances. I click, and that's it. And you see down here, mass and energy balances ended successfully. This is cool. If you have an error, for example, let's go to the operation transfer out. Maybe I use an empty port. So if I now click mass balance, you see, now I've used an invalid port. And now you see that what you will get used to, you see error messages. Stream S04 is not currently be used by any operation in P1. Remember, we kicked that stream out, we used another port. Stream on output 4 in procedure P1 is used by transfer out, but it's currently missing. And therefore, the simulation has failed and the mass and energy balance is not being done. You can only proceed by solving these errors, and you have to go step by step. You will see if you have more procedures, you will get more errors. Yeah. So you need to read carefully what happened. So you see, oh, there is a red, start with the red errors, the yellow errors, but the red errors. So stream on output port 4 in procedure P1 is used by transfer out, but it's currently missing. This means you have to go to this procedure transfer out and check where the problem is. Port 4 was chosen. So let's go operation data. And this is procedure 1. This is vessel procedure 1. You will see, of course, later on, if we have more procedures, how to allocate then the correct one. So this is procedure 1. Right click, operation data. Transfer out. We need to go to transfer out here. Operation data, transfer out. And now we look. So port 4. We have port 4, but no stream is associated here. So, and then we also understand the first message that we have drawn a stream here, 104, which is not used by any operation. Because we have clicked the wrong port. So we have to use port 6 because there we have the stream 104 being associated. Click. Okay. And we redo the mass balance. And now everything is fine. Yeah. Okay. So the mass balance worked. So what? Now it's a big time. We can look what really happened. Yeah. Now we can, for example, right click on our vessel procedure. Operation data, you see we have all this setting. And now we want to go to equipment contents. And we want to see what is happening during our P1 reaction. And here we are. And this is what we see. So you see, this shows us now the contents during the execution of P1. Then we have our charge operation. And you see this charge operation takes 1.9 hours because we need to pump it in. It's often forgotten that pumping takes time. And then you see, as long as we charge, nothing happens, then we charge the second one, and then we have our reaction happening. Of course, we are all aware that most likely if we pump in our sodium carbonate, it will immediately react at the end. Yeah. So, but we don't care. We separate this charge and react operations. And it's not something which hurts us, because at the end, it's just important that after this time here, 4.8 hours at the end, our reaction is complete. This is the point. Whether this has started to react a bit earlier or later, it's a stoichiometric reaction. It's not a kinetic reaction, what we have set up here. We don't care. And then we have the transfer out. And of course, this also takes a while, and we pump everything out. Now you see also what we plan to do is a neutralization. So we pumped in, this already looks good. We pumped in 20% acetic acid and 15% sodium carbonate. And you see that at the end, we wanted to neutralize this acetic acid, but we only partially neutralized it. So we have 30 kilograms of acetic acid left, and we have completely consumed our sodium carbonate. This is the content of R1. What I can also do is I can double click now on this stream here, and then I have the stream content after the reaction happening. So this transfer out automatically puts that now in this output stream. Of course, usually I would then have a downstream operation, that's clear. But you see that this is then exactly the composition of my output stream. I have 30 kilogram acetic acid. Of course, I have no sodium carbonate because this is not in the stream. I have sodium acetate and I have water. And I have only, you see in this stream, I have only stuff which is liquid. There is no gas in this stream. So this is kind of the basic setup. And I think the most important thing at the beginning is just really try out this very simple setup. And now it's your turn. So pause the video and do it yourself. Try to do the setup of the process yourself. And also the second part, please try to do it yourself, the refining of the process before you go on watching the video. So we have now set up our process, and now we want to refine a bit the process and the formatting. So how do we go? Now, first of all, if we have a look again in our equipment contents, during P1, we realize that the pressure, what we see inside there, looks quite dramatic. So we see here, if we look at all this, we have already seen we have 30 kilograms acetic acid left, which is of course something we need to take care about. But you also see that here the pressure at the beginning is 1 bar. This is what we expect. But then it decreases after reaction 1 to 140 bars. This is high. So this is something you should not stand next to such a reactor if you have such a pressure. So we need to take care about that. There is something we need to do. Obviously, if you look at this, it looks like simply we pump something in, the pressure increases, we pump more in, the pressure increases, and here in the reaction we have carbon dioxide being produced. This vessel is simply closed, so we need to open it. So what we need to do first is thinking of where can we change it? And is there something at the equipment? Most likely it will be in the operation, so that we can, in the operation, change something. And if you go to help, you see that we have here this vent valve, and we have connected even already a stream to this vent valve. So this means that this looks like that here at the vent something should come out. So let's see whether we find a way to operate that. Well, this is how you go. It's just try it. Just look for it. It's a complex software. You will not have learned everything before you use the software. You should learn to just try things and then go for it. You should also learn save different versions. So it's now time to save. And then if something doesn't work, you go back to this version, and then you can save the next version and so on. So now let's see in the operations where we could do the things. And if we look at this chart, we see we have the operation operators conditions, volumes, and here we have a tab vent emissions. That sounds good. So therefore, let's go to this and let's see what we have here. Okay, the contents temperature, we are fine with that, but here we have venting. And of course, then if we click, then venting should be enabled. And as you see, the vent stream in this case is automatically assigned. This is the stream 103. And all the remaining stuff we keep unchanged. Of course, in the vent, you could also have emissions, for example, of acetic acid, which is relevant if this needs to be treated and so on, or if you lose a relevant amount of acetic acid, which is clear you have the odor of acetic acid already in your mind if we talk about that. So therefore, there will be in the vent. And of course, this can be adjusted. But for this simple case, we don't care about that. We just want to have the air inside. So we just use an open vessel. We don't have a pressure in our vessel. This you can also do. So we just open it. So that's fine. Now for charge 1. Now we go to the next operation and we use this OK next operation tab and do exactly the same for the charge 2 operation, venting, and we want to have an open vessel. Go to the next operation. It's the reactor operation. It looks a bit differently. You see there are others. There are some other things, but also here we do use an open vessel. And finally, the transfer out operation, also here, venting, open vessel. Okay, and if we now do the mass balance, and if we look now on the operation, the equipment content, you see now it looks better. So we have here the pressure now is what it should be. It's always 1 bar. We have opened the vessel. This is just an example where to look and how to approach it. You will realize that if you use the software, you will have a lot of times things you have never seen before. Just go and try. This is very important. This is the way how you deal with that. Okay, now the next point is just mass flows. So at present, acetic acid is only partially neutralized. So of course, what you need to do is you need to calculate how many. It's clear we have put in 1,000 kilograms of 20% acetic acid and 1,000 kilograms of 15% sodium carbonate. This would be luck if this would have neutralized equally. So what you do is you need to calculate yourself how much you need to pump in. And this is what you then do via the stoichiometric equation. You know that 2 molecules of acetic acid are neutralized with 1 molecule of sodium carbonate. So just calculate what is the molar amount of 200 kilograms acetic acid. Then you know this corresponds to then half of it molar amount of sodium carbonate. And then you calculate how many kilogram these are of sodium carbonate, and then you calculate how many kilogram these are of sodium carbonate 15%, and that's it. And then you adjust that, and then it should be exactly what you expect. But we go to the next point. This is we want to use mixtures instead of pure materials. So what we do now is, for this example, I don't redraw the complete thing. I delete these 2 streams. Now, of course, we have a problem with the process because the incoming streams are no more there. So if we now do our mass balance, we have, of course, error messages here. Yeah. So what we need to do now is we want to have, instead of pure components, we want to have stock mixtures going in. We are at the point 3.3. So now we register edit a stock mixture. Here we go. So we don't have the stock mixtures in the database. We want to have here, we add a new stock mixture, and then we say, okay, new mixture is acetic acid, 20%. This is our new stock mixture. And now I'm having a look whether maybe if we have luck, there is already a mixture which comes close to that. And let's see. Look at this. acetic acid 0.5 molar. So let's copy the default values from this. This is already better than nothing. Okay. Of course, what we have to do now is we have to adjust the composition. So we go to the composition, and this composition we have here is, of course, the composition which comes from this 0.5 molar acetic acid. Now we just adjust that, and we want to have here 20%, 20 mass percent, and this is 80%, and okay. So acetic acid is fine. Next thing we want to add is sodium carbonate. 15%. And here we don't have a real mixture, so therefore we initialize to 0. We say okay. Also double click here. In case of Dart, you use just NaCl, that's already fine, and then change the composition later on. And now we go to composition. Let's put sodium carbonate and water. And don't forget to adjust the percentages. And we update this, and okay. Okay, so now we have these two stock mixtures, and you see by default air is already there as a stock mixture. Okay, so what we do now is we have deleted this stream, so we have to redraw these streams now, of course. One stream and the other stream. And now we go to the selection tool and we double click. And now we initialize the first stream as using a stock mixture. So we click on stock mixtures here, and it's acetic acid 20%. Okay, and we initialize the second stream, and we use again stock mixture, and we use sodium carbonate 15%. Okay, if we now do the mass balance, you will realize you still have an error, because the problem is that, of course, we have not yet told the charge operation that we have changed something. You see, we have deleted the streams and redrawn it, but the charge operation then has lost the stream. So we have to reinitialize also the charge operation. Charge 1, and now the port before was port 4. Now we need to go to, we have connected it to port 5. So this is the stream which goes on. And now we have not put in the stream how much to put. So we need to put it here. 1000 kilogram. Okay. And we go to charge 2. The same as before. Here we have the same. We use, yeah, we had luck. We had connected to the same stream. Set by user 1000 kilogram. Everything is fine. Okay, so now let's do the mass balance, and you see everything is fine, and it should look the same as before. So if we go now to our equipment contents during P1, you see that we have basically the same values here. So the same, just looking at the acetic acid, you see also here we have 30 kilograms acetic acid left. So everything is fine. We have correctly done that. Now the streams and so on, looking at these streams, it's hard to see what is getting in. So therefore it makes very much sense to assign to the streams the names and assign to the vessel procedures the names. This is the point 3.4 to add labels. That makes the overall process then way easier to see. First of all, we give names to the stream. So let's put it up. And if I right click on the stream, I have the point edit labels. And then I can say, okay, this is acetic acid, 20%. This is just a description. So if I pump in there a sodium carbonate and I name it acetic acid, then of course the software will not complain. So make sure that it's the thing what you write there is also inside. 15%. And then we name this stream vent. Right click, edit labels, vent. And we name this stream, for example, product stream, because if we want to produce sodium carbonate, this would be sodium acetate. This would be our product stream. And of course, we can also edit the labels of the vessel. And we could say, okay, this is neutralization. Okay, so this is neutralization R101. And then we know what is happening there. And then what is, of course, interesting, we can also put the style, and we can say, okay, I want to have the content which is actually going in. So if you have many streams, it's good to see what is the actual mass flow, even what is might be the mass flow of one component. And of course, you can also do that. So in this case, we go to stream style, click here info tag, and then we have here an info tag. And what we want to have is, let's say, the total mass flow. We're fine with that. You see, you can have also other options. And then we can choose the location. So on vertical segments, it's located like this. And on horizontal segments, we also want to have it localized over the stream. And then we are fine. Okay. Now, if you, of course, need to do that with all streams, this takes a day. So what you can do is you can simply now right-click the stream, style, and then simply pick up style, choose pick up style, and now things are easy. Right click on the other stream, style, apply style. And we do the same here. Style, apply style, and here style, apply style. And now the style is obviously applied to the others. So this is how you can make it a bit more look a bit better. Okay, so this is the first part of the example. The second part of the example will come then when we talk about the economics part. So this I would propose, this we will do in an extra video, which will be quite short, but this is then also nice that the videos are shorter. So this is the first part of the example, how to set up a very simple neutralization process. I would strongly recommend that doing it yourself and then maybe looking from time to time in the description. But now I would like you to do it, start right away, do it yourself in order that you learn how to use the program. And then we go to the economics. Thank you very much for your attention and goodbye.